In this video we have a Pythagoras theorem. We have an algebraic problem. We have this right triangle, and the two vertical sides are given in terms of x, and the hypotenuse is the square root of 2. We would like to find what is the value of x. So we employ the Pythagoras theorem. We take x squared plus x squared squared equals the hypotenuse squared. So this can be written as x to the power of 4 plus x to the power of 2 equals 2. I take a 2 to the left hand side, and the equation becomes x to the power of 4 plus x to the power of 2 minus 2 is equal to 0. I set omega to be x squared, and I recast the equation in the following form: omega squared plus omega minus 2 is equal to 0. This is a quadratic equation, a trinomial, so I find the discriminant is 1 squared minus 4 times 1 times minus 2, 1 plus 8. So the discriminant is positive. I have two solutions, omega plus the first root is 1, and consequently I can also find, apparently I can find the omega minus the other root of the trinomial, which is minus 2. But I have to switch back to the original variable x squared equals omega plus x squared is equal to 1. So I have to solve this equation. It's a difference of, this can be written as 1 squared. So I have the product x minus 1 times x plus 1 equal to 0. It's a double bracket equation. X minus 1 is equal to 0, x is equal to 1. X plus 1 equal to 0, x equals minus 1. But this is rejected because x is a length. It's in terms of x is a strictly positive quantity. So I keep this one. Now let's go to the other one. X squared equals omega minus x squared is equal to minus 2. So x squared is plus 2 is equal to 0. No real solutions. So my only option is x to be equal to 1. So indeed, if I put x equals 1, so it should be 1 squared plus 1 squared squared. This is 1 plus 1 equals 2. So the hypotenuse is square root of 2. This is a nice problem because we combine geometry with algebra. So we see here that we obtain, this is called a biquadratic equation. This one is a biquadratic. We change the variable. We solve the trinomial equation, calculating the discriminant and finding the two roots, and then we switch back to the original variable, which is x. And the only acceptable solution, so one equation is impossible to solve in the set of real numbers. There are no real solutions for this equation. And for the other equation, we only keep the positive value because we deal with lengths. As a consequence, we get that the only solution is x equal to 1, which satisfies here the Pythagoras theorem.